In this episode, I'll show you how to script your own rope or wire using Unity and C#. And in an upcoming episode, I will show you how to generate the mesh for the rope. So if you like to see that, make sure to subscribe. Let's get started. Hello and welcome to another episode of Game Ideas to Steam. Today we're going to try to create a rope simulation of a wire, or would you like to call it, whatever you like to call it. It could be something that connects two things. In this case it will be quite simple, just creating a bunch of segments, combining the joints and so on between them. So let's jump into Unity and start building our test scene. So as you can see, we need to have some kind of reference object just to make sure that we see what we want to see. So let's create a plane, a simple plane, so we know where we are. I like to be in orthogonal or isometric view. We want to have the wire object. We want to have an object for the start, wire start. We also like to have a end, like so. Can place them inside, and we should also create where we should create all the segments. Right, so starting by placing this in the 0 position. Roll plane. Pull that but a bit up. Start. Let's pull those apart. And the segments, yeah, it can be wherever it's like. It's just a container of the physical of the game IDs. Game objects. Okay, so we need a new script. I got a script for the wire. So let's jump into some coding. So we have a wire script, mono behavior. So we want to start by defining the transforms for the start and the end. Start and the end transform. We want to define if it's how many segments we should have. 10. We should also have the total length, because it will determine how long each segment should stretch between the joints, and that will have a float. Total length, let's say 10 as well as default. The weight, float. Total weight, let's set that to 10 as well. 10 is a good number. And we can also right. We need to keep track of all our segments. So let's create a transform array for segments. We need to define the segments parent, where they are created in the game hierarchy. Right. Yep. So when we reload this in Unity, we should have all the parameters that we need to assign. We should drag the start to start, end to end, and segment parent segments, the container for the segments. Right, so let's jump into the code again. So when we start this, we need to create all the segments. So let's create a function for generating all the segments. Generate the first segment that we should use, or is we should assign the start segment to be the previous. You'll see down when I code some what I mean. So transform previous. No. Should be start transform to begin with. Then we need a direction, because when we're creating the segments, we're starting from the start transform to the end transform, so we need to create a segment between them. So we need to create a vector 3 direction, which is the start its end transform position minus starting point position. So then you get a direction in which. So what we can do is also normalize that. Normalize. Right, so we have a direction to start with. Then we need to loop all the segments that we need to create. So for loop, I'm gonna create for segment count. Okay. So this will create 10 instances, 10 segments in this case. So we'll start by creating a game object. Game object segment. New game object. And you can enter a name if you like. So let's create a segment number I, like so, right? We should assign a parent. So let's just make sure that that works by going back to Unity. Focus. There we are at 10 segments. Right, so that works. To the code, we have the segments. So what we need to do now is to move them between all the between the start and finish. So let's calculate the position, and that's a vector 3 position equals. So we need to create the position. So position equals the previous transform position, and we should add the direction sorry, because the between the remove normalize, because this vector will be a vector from the end to start. So we'll use the direction equals the amount of segments, segment count. Yeah, so it will then we define the final assigning previous transform. Good. So we need to visualize this somehow. So let's on Gizmo on draw for each segment length, segments length, we will Gizmo draw wire sphere at the center of each segment. So segments I dot position with a size of .1f, so Okay, right. So of course it didn't, because we don't have assigned any of the segments to the array yet. So let's do that. This segment is always empty because we're not assigning it. So we should start by segments. Create a new transform array with a segment count, and for each segment we should add the transform I segment transform. And now it should be working better. So as you can see, they're all on the same position for now, but at least we get some gizmos. So let's see if we can move them, assign them to their new position according to what the... So let's jump into the... We have the position, so we need to assign the position to the segment. There we go. Position, right. So in this case, we should also get the correct position in Unity. Let's jump back to Unity and see how that goes. Right, and we already have the start here, and we have the end there. Nice. So let's assign a small... So now we should have a bunch of segments between here. Okay. Good. Right, so next up we should try to create the linkage between all the segments that we're creating. So let's do that. For that we will need some kind of join function. So let's create a join segment function. Right, so in this we will take the current transform current, and also which one it's connected to. Right, we should also take in if it's if it's is kinetic or not. So it's kinetic because we need to apply this to the start and the end as well, and those two are usually kinetic, so they are, yeah, they're not affected by gravity or physics rather. False. We put it as false as default. Yep. So we're missing some. So the current segment transform, also the previous transform, but also if it's connected, is kinetic. And in this case, for all the segments, they should not be kinetic, but for the start one, for the first one, it should. And the first one, since this one is we can add null, I think, so we don't have any connections, because it works like this, that the first one is just, it's placed in the space. The second one is connected to the first one, so they are connected to the previous one. So the first one doesn't have anyone to be connected to, but it should be kinetic. So let's type in true here. So inside the join segment, yeah, well, we should also connect the last one. So after it, we should also put in the end transform, but also, and that should be connected to the previous transform, and it should be connected. It's kinetic. Sorry. True. No, false. because the linkage between those two should be yeah. Create a new read body, current component rigid body. All right, and this rigid body should have some mass, right? And that we have the total weight divided by segment count. It should also have grid body drag as to drag. Yep. Also ridge body angular drag, right? So this is the one that's controlling if it's really kinetic or not kinetic. It's kinetic, right? So we have the read body applied. So what's happening now is that we have created all those segments, and if we have the wire set to total weight of 5 instead, they should all have like 0.5 instead. Yeah. So, but they're just falling, so let's fix that. Now we need to create the configuration, the configurable joint between them. If they have a connected transform, we should create a new joint. Configurable joint. Let's just call it joint, new configurable joint. Right, so there we go. Not like this, but current add component configurable joint. We should join the connected body, because connect the transform, and this is the reach body. Get component read body. There we go. What else? We need to set the different limitation of how the joint should be able to move, and we should also disable the not that one, the auto configuration connection, auto configure connected anchor, because we want to determine that ourselves. So let's put it to false. And if we have yeah, right, so we need to add a new boolean here as well. Boolean is close connected. It should be default true. And those should be is close. Should be true for this one, and false for the other two, because they are a bit separated. It's just the end transform that is really close to the previous transform. So let's get back to this. If is close connected, it means that we need to set the connection joint to be really close. Right. Connection anchor, which is a vector 3. Vector 3 dot forward, just so it will be closer to the connected transform. Forward times 0.1 f, right? But if else, then it should be the same distance as between the segments. Right, so not vector 3, but rather vector 3 forward times total length divided by segment count. Okay. So this will be applied for the last, for the end transform, and this will be applied for the start and also all the segments. Next up, we're going to create the different kind of motions, how the joints should be able to move, both in length and rotation wise. So join, let's start with the X motion. It should be a configurable joint that should be locked. We should have locked for all the motion in Y and Z as well. But the rotation wise, the angular motion, there we go, should be free, except the Z, because that should be have to be able to move. This means that the joints will be able to move in the sideways, also up and down, but not rotating, because Z is forward. So between the segments, they should not be able to rotate freely around each other, because that will make the rope kind of twisting itself. So we will limit that, so it can rotate a bit, but not much. So let's create the limitation for that. Joint, limit. Nope. We need to create a soft limit first. Soft limit. Soft limit, new. There we go. Soft limit joint. And we should add a limit to this. Limit 0. We should apply that one. Joint angular set limit, right? Yeah, the soft limit. Yep, I think that's it. We also need to set the drive joint. Joint drive. Drive dot position dampering to 0. Joint drive position spring to 0. And then we should apply those. Your X drive. There. Drive. And also the Z. Oh, sorry, Y. Not called that. Angular. Oh, right. This one. Good. So now we're creating a read body, and we're connecting a joint from current to the connected. So let's see how that goes in Unity. So back in Unity, let's press play, see what happens. Whoops, we have a bunch of segments falling around. Let's see where's the end. Oh, okay, so the end is the wall. It looks like we have a segment between, and there it broke. As you can see, we have some kind of rope-ish. Nice. So since the rope is flying around, the last one is kinetic, but it's set as false here, so this should be true. So now we have the start, we have the end, cube is a bit off. Let's pick that visual, so it should be in the middle. That's in the middle as well. Right. We have a kind of ropish. Let's add some physics so it can interact with elements, so it doesn't fall through the floor. Because this already has a mesh collider. Let's see if we can use physics. So after this, we'll add a new serialized field, a boolean, use all. So if this is set to true, we will add let's add a collider to this as well. If this is true, then we'll add circulator. Current, get component, add component. I think we should make it a bit smaller because we don't know how thick the rope is. So let's add a serialized field for that as well. Float value for radius. Let's put that to 1.5. So then we have a radius for the rope, and that will also be the radius for the circulator, of course. Circulator radius. Okay, I think that's it. Back in Unity, let's see if that works. It does not. Of course. Yes, physics. Wow, they're huge. So let's see what kind of radius would be suitable for. So let's go for 1.313. Wire stop radius 0.13. Then we have a wire here that will, as you can see there, they are let's add the amount of segments just to see how that will look. So let's jump it up to 50. Let's take a bit shorter, like 8 length. Yeah, so now it's starting to look like a jitterish. I think it's the colliders that are jumping due to they're so close to each other. So I think that's a bit too many. Or just would you add the length to 15? It's kind of working. There's always some things with the physics. Okay, cool. Let's preset that to 10 and 10. Okay. So if we like to change all the values in runtime, we need to move the generating of segments into the update. So let's do that. And it's more for testing. So that's not something you do when you're when we're doing the if you have it in a game or something. Update. So let's move the segments in there, but also the amount of segments, because we're changing this. But we should only change it if the amount change. So let's create a new parameter called rev segment count, and assign segment count for that one. Just the integer up here. If previous segment count is not the same as current, it means that it have been updated. And if they have, we should do this, and we should also generate the segments. Right. But this will just create a bunch of new segments, so we also need to remove the old ones. To do that, we will create a for remove segments. In this, we will loop through all the segments for segments length draw. Let's make sure that it's not null. If segments I not equal to null. If it's not, then we will destroy it. Segments. This is a transform. You can't destroy the transform. You have to destroy the game object. So we will destroy them, and then we'll create a new one. So let's see how that goes in Unity. Right, so we got a small error. The error is that it's trying to add a ridge body to it's already created. So let's make sure that we don't have any ridge body on this one. If current component ridge, if this is equal to null, what? Oh. And I think we need to do the same as for this one. So we start by trying to get it. If joint is null, then we'll add it. So let's see how that goes in Unity. See if it likes us now. Wow. Okay. 4. So now we can play around, see how many anchor points we need. And in this case, we can add a bunch. Wow. We can also can't change the length just yet. but yeah, let's fix that. Yeah, so if we're changing the length, radius, weight or something, we need to be able to update that as well in the runtime. So let's create we'll update the rope if or if drag is not equal to drag or if the create angle or drag is not the same as. So how do we do that? Well, we need to loop all the segments for each segments length segments length. Okay, we'll do it like this. If I equals 0, else they will have two different kind of things. Update length on segment. Well, let's send in the segment I, the new length. This is wrong. Sorry. So if it's not the first one, we should only update the length. If it's not the first one, we should update the length. Correct. Yeah. So total length divided by segment count. Right? We need to create this method, but we should also, for everyone, for all the segments, we should update the update weight on segments. So we are creating two different types of functions. Drag, and angular drag. Right. So now we have two new functions we need to populate with things. So for each, let's start with the length of every segment. So for this one, we will get the configurable joint. Configurable joint equals transform component configurable joint, right? We should set a new length. If joint is not null, then we should update it. Joint don't connected anchor body, which is vector 3 in the forward direction. Forward times the new segment length, which is the total length divided by segment count, and that's it. For the weight, we should get the git body, transform get rigid body. Thank you. And for that, we'll update rigid body mass, total mass times segment count. Rigid body velocity, no. Drag equals drag. Rigid body angular drag, Right. So for all segments, we're updating the weight. For all segments except the first one, we're updating the length. Okay. So let's see if that actually works in Unity. But some of you might have caught me doing some bad things, so we need to actually do the update before setting the new previews. Otherwise, this will never happen. So let's jump into Unity again and see if it actually works. Press play on tape. We're getting our spheres, changing the length. You can see it tightens together the rope. Can add more. Can add length to this one. Or keep it really tight. So why are you doing this with the rope? Let's change the drag. We can play around with those values to make it. So you see there's a bunch of drag. Too much drag. I think if you have the anchor, yeah, right. So if the distance between the physical object, so the game object and the anchor length connected body is too small, it starts to jitter really much. You can see when we find the threshold right there. Good. So let's see if we can update the radius as well. So back in, we should see if we have the so let's create a previous radius equals radius. If previous not equal radius, then we should radius. And for the updated radius, we're going to loop all the segments, of course. And we're going to set radius on segment. Now we're sending the segment I and the new radius. Transform get circulator. Let's store it into set the radius to this one. Circulator radius. Right. That should be it. Let's check in Unity if that works. So we have our wire. There's something wrong. Circulator is not attached to segment 1 because it's not physical. Yeah, of course. So this should only be applied if it's not the same and is use physics. What? Also, the radius should be applied to the gizmo. Let's see where to find the gizmo draw. There we have it. Radius. Let's jump back to Unity. Now we can set the radius. So if we want to use the physics, let's add 8 physics things. So let's find the sweet spot for the whoops, daisy. 0, 3. So what will happen if we add a cube? It has a box collider, a wire, radius. Okay, sounds good. Let's use physics to change the length, add some segments. Will it work? Yes, it does work. So we have a rope, working rope. Of course, it can create some jitter and so on. Cool. So what's next? I plan to use this function in the game actually as for cables, maybe for the cables for the lifts, but also for wires from example the TV or something similar. So in the next episode maybe we'll go through how to generate the mesh for the rope or the wire or the cable, call it whatever you like. So thank you for watching, and I hope you had some good time and learned something. I sure did when creating this for the first time. So thank you and see you in the next one.